schedule this week. Our principal, Mr. Pelche, called a staff meeting yesterday afternoon, and as a result, I couldn't have our class at its regular time. So I had to push it to today, and 1 o'clock today, I usually have my IB class, so I pushed it to this 2:30 time. So I understand that a lot of you can't tune in at this rescheduled time. It's like at school if all of a sudden our course was changed to a day and an hour later. So, but I am recording it for everybody, and my hope today is to complete the collections example, completing the course content in terms of examples, and that will be kind of everything, right? It'll be everything all done today. And what I have on the agenda for next week is discussing just kind of the last few little things I would expect for you guys to do to essentially finish this credit. There's no real need to do essentially anything other than engage in online learning. That's what you need to do. So if you're thinking, I have to do a final project, I have to do this, there isn't a lot of have-tos at this time. So we'll discuss kind of all those options next week. That's the goal of, anyway, so let me share my screen. And so from our 40S class, or from our website to the 40S class to this week, week 15 right here, okay? The video started last week, went over collections, and today I want to continue that collections example, looking to finish it today. And then, as I said, then there's only a few weeks left after that, right? If you think about it. Eventually, these next 3 weeks after this week will complete this year's school year, right? June 1st to 5th, 8th to 12th, and 15th to 19th. And actually, this isn't even really a full week, because essentially June 15th is essentially the last day that the school is essentially expecting teachers to do it. All right, we still good here. Sorry, my screen seems like it's frozen here for a sec. Let's see. Oh, it says it's still recording, so I think we're good. Okay, so that's the deal, okay? As I've outlined, and again, I'll go over this next week, the reasons why I'd want you to continue is especially for those of you who are continuing on in IB classes with me, say next year, or continuing on in computer science post-secondary. So you can download the example from the GitHub page. You can read about collections from my presentation, or you can watch all the collections videos from the past that really outline the specifics of collections. But what I want to do is just focus on just working on this example today and getting it done. So our example has a node class, which we completed, and a linked list class, which we've mostly completed, and a collections test class where we run tests on the code we type in. So with the node class completed, we'll be working on linked list and collections, and it's all incorporated into the big example we've been working on since the beginning of the 40S course. Okay. Collections test is just a place we place code to test it. It has one little method just to make a nice little comment. I can run the collections test, which tests the linked list code that we've been using, and it also tests the node code as well. And here you can see the collections test is complete. It started with testing some nodes and then testing the various methods built into the linked list, okay? And then it's done. That little comment method just makes the text a little different color and adds some dots to it, just so I don't have to double it up. I can write a comment essentially in the code and call it as a comment for testing, in the same idea. Okay, some space there so we can add our next testing piece after what was there already. As far as the linked list is concerned, I'm going to show you it from the perspective here of the navigator in NetBeans to show you all the different methods that we've already incorporated into it. A constructor method, and then a series of adding methods, a whole bunch of adding methods, some getting methods or accessor methods, a set or a mutator method, some new removal methods to remove things from the linked list. So it shows the superiority of a dynamic data structure like the linked list over a static data structure like an array. All right, collapsing those methods. The last method we worked on last week was our remove method. It deletes a node at a specific index and essentially changes or mutates the list. Today, what I want to write is a public int searching method I'm going to call first, index of this piece of data. So the idea is it finds the very first place in the list where the data occurs. The data might occur in several places in the list, but this will give us the first place. Okay? So if the data is null, then I return, and here is where I can use that integer not found that we created back at the beginning. Not found equals the number -1, and so that works out really well. Okay, again, you might remember this was something we created way back at the beginning of linked lists. It's just I thought it would work out later, and it does, for us to just put that in there. So if there's the data's null, I'm going to say no. There's nothing in there. I'm also going to have that occur at the end of this method. If I can get all the way down to the end of this method, I won't find it. Okay, now to find it, I'm going to do a classic search or traversal to travel through this linked list, starting at the head of the list. So I'm going to make a reference called current, started at the head, while current is not equal to null, because null would indicate it's reached the end of the linked list. Oops. Okay, we're going to get a loop going. Inside the loop, current will be next. Move it to the next reference each time. I'm also, just before the loop begins, going to create an integer called index, started at 0. And then every time I move to the next node, index goes up by 1. So this is kind of like a for loop in some ways. It starts at 0 and goes up by 1 each time it moves to the next node. And then all I need to have in here is an if statement. If current dot data inside of current dot equals the data that's passed to this method as a parameter, if it equals that, then just return the index number. That's the spot where I found it, right there. Right at that index number is exactly where I found that data, which satisfies what this method needs, is find the first spot it occurs at. That will also stop the loop, because returning from a method stops the loop. But if I can make it through all the way to null and never find data that equals, I return that it's not found. So it's a pretty simple method for that purpose, right? Now I'm just going to run the code real quick right now so I know exactly kind of what we're looking at here for our code. I think we were doing some removals of the front and back of linked lists. Yeah, we were. But I think we were always, if I remember correctly in our testing, we were dealing with things like list 2 when we were removing, okay? Whereas list 1 should be basically left alone. So I'm going to test index of method. First, I'm going to output the list, and I'm going to output list one. And then I need a number to look for. So I need a number that perhaps I know is in the list, and maybe the one that's at the very first index. So I'm going to output, well, actually, we have a variable index equals. So I'm going to pull the index by saying list1 dot the first index of, so I need some data for this to occur. So my data will be equal to, I'm going to go to list 1, I know, and I'm going to get what's at, actually, let me get the first to the front. I know that data is right at the front. I have the index number, okay, of where it is. and then I have the data that I'm searching for. Okay, let's output that. That data found at okay. Okay, so let's see how that first test runs. There it is. It says data, the 4 was found at spot 0. That makes sense. That's where it is. So that's one edge of my linked list. Okay, let's do it again by going to the back. And I'll do that. And there it is. Found the 16. It found data 9 at spot 16, right at the back of the list. So it was able to do that. Okay, so I tested 2 edges of my linked list. Let's test a random number. Okay, so the random piece of data, I can get, how do we do that? Yeah, here's a random piece of code to generate a random integer. That'll work out well. So I'll make my data that way. I will use the first index of to do it that way, and then output it that way. Okay, let's search for random data. It's possible it won't be in the list. It's possible it will, right? But where will be the first index of that piece of data? Okay, so it says it found a 4, which was randomly generated at spot 7. So 0, 1, 2, 3, 4, 5, 6, 7. There it is. There's the 4. Okay, that was the first index where 4 occurs. Okay. So that works pretty well. I'm going to do one more test. Okay, and to do this, I'm just going to go back and take a look at what my high and low were, which were random or were constants that we created in our test at some point. I'm just trying to remember where. Some point in this code, we made right here. High and low is 0 and 9. That's what I thought. So I'm going to make data a number that I know isn't in the list. I'm just going to make it 10. Okay. 10 will indicate that it's not in the list. There's never a time where 10 will be in the list. So running that should show me a test of it not occurring in the list. So it should return that it found it at -1. And it did, because there is no 10 in this linked list of numbers because they're only 0 to 9s. Okay, so that was a pretty good test of first index of. Now, what I'm going to do is use this code to build pretty much an identical method, but I'm going to call it the last index of. Okay. So I'm going to reverse my logic here a little bit. So now I'm going to find the last place in the list. So to do this, instead of going from the head, I'm going to start at the tail. I'm not going to start at 0. I'm going to start my index number at length of the list, -1. So that's the last number. The loop will still keep going while current's not null. It'll still have the if statement if current.data equals that. But now, instead of going to the next node, I'm going to go back to the previous node. And instead of adding 1 to the index, I'm going to subtract 1 from the index. To test last index of, I'm going to do basically the exact set of tests I did on first index of, but instead change it to the last index of. So I'll go to the back of the list here, or actually no, that can stay the same. So every place I have the word first is going to become the last index. Just make sure I didn't miss any of them. Nope. So the first index and the last index. Okay. And actually, let me add that to the output. So well, no, I don't have to because I have that comment line. So I think we'll be okay. All right. So let's run this test on the last index of. All right, so now it says it found a 0 at spot 15. That's the last place it found a 0. There was a bunch of zeros at first, but then the last one was at spot 0. It says it found the 9 at spot 16 here, which makes sense. That's the last place it occurs. It found the 1 at spot 2. So there's the 1. It found this was not found. So there's lots of different ways you can run that test. The 0 is a weird number because it would occur multiple times in the list. I'm just going to run that test again. Okay, so this here you can see the 7 is supposed to be found. It finds it right here. So anyways, it does work. So there's our last index of method, testing a whole bunch of extreme situations in the code. All right, next up on the linked list is we're going to make a public integer number of method that takes data parameter. Now the point of this method, number of, is it counts how many times this data is in the linked list. Okay, so like you saw in the previous test, sometimes a number can occur multiple times. So now we'll count it. So if the data is null, then I return 0. There is no places where that would occur. Easy catch right at the beginning. Okay. Now I'm going to make a counter variable starting at 0. At the end of this method, I will return that counter variable. So that's going to be doing the counting. Okay. But then I essentially can do the same type of looping I did in first index of. So to save a little time, I'm going to pop it back in there. I don't need an index anymore. That's not necessary. I still will do this, but I also don't need return anything when I find it. When I find it, my counter goes up by 1. So that's all it does. And actually, I don't really even need brackets for that. The counter goes up by 1 every time I find that the data inside the linked list equals the data inside of the data from the parameter equals the data at current as I loop through the linked list spot by spot. Okay, so we can test number of, and we can kind of use the same sort of stuff here that we did with last and first index of. So I'm going to use the same sort of testing system to test the number of method. So here I'm going to use number of times that data occurs instead of the last index. Okay, and instead of saying found at, I'm going to say that this is the count of how many times I found it. Count of how many times I found that particular value was this number. So let's test that and see what kind of comes out of that. Just putting a quick test together here for this thing called number of. Okay, so it says the number of times it found a 3 was twice. So there's a 3, there's a 3. So yeah, that looks like twice. Number of times it found a 9, just once, it says. Number of times it found a 6, just once, it said. And the number of times it found 10 is 0. There are no times it found a 10 in that list. Okay, so the test looks pretty good. It's counting the number of times that it can find a certain thing in a list. So those are 3 really good searches. The first time I find it, the last time I can find it, and the whole number of times I can find it. This next method incorporates it in a slightly different way. It returns an array of integers called all indices. Indices is the plural of index. So what it's going to give us is an array back of all the index numbers where a piece of data is found. Okay, so first of all, if the data is a null, I'm going to return a null. I have to return something, and the something has to be an array. But if there is no data to look for, I'm just going to return null. There's no array to create here. Okay. And okay, so I now realize that in order to incorporate the next thing I want to do, I'm going to pause and quickly build a different method first. So I'm just going to comment this out. thought I had made this method, but I was incorrect. I have not made this method yet, so I'm going to make it right now. Actually, let me just, yeah. Okay, so we're going to make a simple search method, public Boolean contains. Does this linked list contain this data? Yes or no? It is essentially the same code we've been doing up to this point, like right here, okay? So I'm going to steal it from number of. If the data is null, return false. It does not contain the data. Then make a node current equal to the head. If it equals the data, return true. I found it. And move to the next node, and the next node. Okay. And if not, return false. Yeah, what did I miss there? I don't feel like I missed anything. Let's just try that again. Oh, it's probably because this method down here is throwing it off. There we go. Okay, so that's my contains method. Does this linked list contain that data? It's a pretty simple test to run, but let's run it. Okay. Test contains. Okay, and I can basically use the same stuff, okay? So contains, but this will return a Boolean, not an index number. So what I can do is I can just pop this method call directly into here, okay? Does it contain that? Yes or no? So I don't really need index at this point. I just need this line here. Does the linked list contain this data? Yes or no? Okay. So I'm going to replace these with that line. And here. And here. And I don't need this index line anymore. I just need to make different data each time. There we go. So I get the data from the front, I get the data from the back, I get the data from a random integer, I make the data 10, and let's see if the linked list contains that data. It should contain front and back. It may contain the random one, and it will not contain the 10. So as you can see there, true, 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 and false. So it did contain a 5 for sure. Okay. So that's a simple searchable method. Does the linked list contain that data? Now, the reason why I had to pause to make that is I'm going to use that with my all indices method. Okay, it's just a method that will be, it's dependent on that one. Ooh, okay, so if it does not contain the data at all, then I can also return a null. There's no need to build up a big array of indices if the data is not even in there. So I can use that as just a quick check. I'm not going to go through and find all the data spots if it doesn't contain it. So I'm going to just use that as a quick check. All right, now the size of this array, okay, will be the number of times it occurs. The number of times it's in the linked list will be how big the array is. Okay, so now I will make all the indices by making a new integer array of that size. Okay, so now I have an array of those many indices. At the end of this method, I will return those indices, all those spots. Whoops. Indices, again, the plural of index. But now I need to fill it up. Okay, I've stated that I've made an array. Now what I'm going to do to actually fill it up is, again, use code very similar to what I did up here, okay, with a loop through the linked list, like I did with number of, counting, okay, having a counter variable. This time the counter's for a different reason, starting off at the head, okay, and what I'm going to do instead of the for loop or the while loop is a for loop, going through the length of this thing, okay? And what I'm going to do here is inside the for loop will be the same basic if statement. So I'm going to steal that little if statement from down here. Okay, if it equals the data, okay, the array at that counter, okay, actually, you know what, instead of counter, why don't I say index? That makes sense to me. This index number equals whatever spot I'm at in the for loop. So the array, which is actually called indices, this index will be equal to I. Okay, my index number now goes up to the next spot in the array. And if the counter, or if the index, pardon me, is greater than or equal to the size of this array, then I would at this point also return the array. That array would get returned. That's kind of an error check in there, okay? Just in case I don't exceed the end of the array. And then outside of the if statement, I would need to do this line again, current equals current dot next. That line would still need to happen to advance the node to the next node. Okay, so backing up, that's this all indices method. It's actually kind of a tricky method there. So we're going to test that. All the indices method. And the way we're going to do that is we have to make an array. Okay. So we're going to make an array of all the indices by going to list one. And from list one, we're going to pull out of that all the indices of a specific piece of data. Now, the data we'll get will be first from the front of the list. So we'll pull it out of the front of the list because we know that's in there at least once. So it'll have at least one spot. And now we have to spit that out. We have to spit that out in a piece of text, I guess. So a way to do that, do I have the tools set up? No, I don't have it set up. So I just need my array in a nice format for me to be able to spit it out. So I'm going to just quickly make a little method to do that. A little private void. I'll just call it toString. No, I won't call it that. I'll call it just array of a integer array called A. Okay. I'll make a, and it doesn't return void, pardon me, it returns a string. Sorry, I'm making this kind of up on the spot here. A string of text equals an opening bracket. At the end of this, I return that text and I attach the closing bracket of the array. And in the middle of it, I run a for loop. I can even use a fancy for loop, but I'll just keep it to be the simple for loop up to a dot length, but I'm going to go to 1 in front of that, so -1 text plus it onto the text. What's in the array at spot I plus a comma. And I just keep doing that over and over and over again. And then before I'm at the end of this thing, I'm going to put the very last spot of the array on there. Array spot array dot length -1, so that I don't have a weird comma there. Okay, don't sweat it too much. This is just a little method that will hopefully make the array look nice, because I want to do that right here. I want to output that my data, which was this thing called data, and the indices where that data occurred was at, and here I can call my little array method with indices, the array indices, which is an integer array. Why is this? Oh, it's versus. Okay, so I'm going to just turn this into this. We should be good to go. Okay, let's just run that first test before I get into other testing. And let's just see how that goes. Do I have an error? I might not. No, I don't. Okay, good. Let's see how the test goes. And there it is. It says it found a 4 at spot 0 and spot 10. So here's the 4 at spot 0, and then there's the 4 at spot 10. So it did pretty well. Okay, did pretty well for that. So then all I would need to do is keep redoing this over and over and over again. Okay, which I'm going to. I'm going to test it with the data from the back of the list, like I did before. I'm going to recreate the array. I don't have to redeclare it, but I'm going to say indices equals that, and then I'm going to do an output right here. Sorry, bud, I can't help you right now. And then I'm going to get the data from a random number. And then I'm going to recreate the array and spit it out. And then finally, I'm going to use the data that is for sure not there, and then spit it out, which actually will, I see a potential error there, which I'm going to catch in this little method here, because if my array is null, which is what would happen, I'm just going to return the word null. That should hopefully catch that, because there will be a time when the item isn't in the array that could occur. So I don't want that to crash my program. So here's my test of all the indices, and let's kind of see what kind of test data we get back from this. We could do some really good testing on our method to see. And there we go. So it's, you can see it's here. It's finding, oh, there's one spot there, and there's no 10s in the linked list. I'm going to run that test one more time just to kind of see. Yeah, does pretty well. Just doing it one more time because the random number kind of helps get for good testing. There we go. So for example, this one, it's saying it found zeros kind of all over the place. At spot 1, at spot 2, spot 9, at spot 15, it found a bunch of zeros. Whereas the 2 it found at spot this, and it found a 2 there. So you can see here this method is working really well to do all that. Okay, quick video check, all is well. All right, the all indices method. All right, now the reason why I've kind of built these up, these searchable methods, is I want to expand on our remove methods that we already have. We can remove the back and the front of a list, and we can remove a certain spot in the list. Those are all options we have built so far to remove in that way. But let's expand on our remove methods a little bit. So now what I want to do, okay, is a Boolean method, remove, but this time I remove data from the list. Removing an index number, I'm removing data. The place where this data occurs in the list, I want to remove it. Okay? And what I mean by remove here is it's going to remove the very first one. Okay, so this is actually a pretty short method. If the data is null, then nothing to do there. I return false. Nothing to remove in this. Okay. The bottom of this method is true, that I was able to remove it. Okay. Int index, the first index of that data. So I just find the index number. If the index equals not found, well, then I return false. Nothing to do there. Otherwise, I just remove it based on the index number I just found. So here you can see again a method that has a lot of dependencies. It's dependent on methods we already have. Okay. Now, before we go and test this method, I'm going to make basically an exact copy of this method. I'm just going to name it remove last. It's going to basically work the same as the remove method here, but remove the last spot in the linked list. And all I need to do to change this is from first index of, it becomes the last index of. But the rest of the logic is exactly the same. All right, so let's put these methods to the test. And let's test our remove. Oops. remove data method and remove last method. So these are the two methods we can test, okay? So we have to have data to remove. So I could just start by getting it from the front of the list, which I could do right here. Okay, maybe I'll spit out the list first. So I'm going to output. Actually, we don't want to mess with list 1 since we're actually removing something. So we're going to copy list 1 onto list 2 again. So we can mess with list 2 and list 1 remains untouched. So equals list 1 dot clone. Easy enough thing to do. Okay, so we'll get that from the front of the list. We're now dealing with list 2, and we're going to do a removal of that. So output remove indicate whether it was true or false. And so list 2 dot remove that data. And then we'll say display the list after that, just to see. Okay. Let's just see what that looks like before we do any further testing. And let's see what list 2 removing a piece of data looks like. All right, so it says, yeah, I was able to remove the very first 7 I encountered. And you can see there, this would have been the first 7, so it absolutely did that, okay? We will now do the exact same thing over again, but test it with the back of the list. So now different data will come from the back, and then we will do it again, but this time we will do it from a random piece of data that may or may not be in the list. And then we will do it again with data we know isn't in the list. 10. 10 is not in the list. So here's me removing it all nicely that way. And what the heck? Let's do this all over again. But this time we'll remove it from the back of the list. Okay? So we'll remove the last piece of data from the list instead of the first. So remove the last, remove the last, remove the last, remove the last. It bugs me a little bit that that is going over that red line. So I'm just going to make adjustments. Programmer, as you probably guessed. Okay, almost there. Just so I know which is which, I'm also going to add the word last to these last ones here. So just the word last. Going to get added into here. So I know that that's the method that's being called. All right, let's test a Rooney and see what happens. Trying to go really quick here to give you the gist of all this code. And there we go. So it removed the 7, it removed the 9, removed the 1, could not remove the 10 because there is no 10. Okay. And then remove the 0. This would be the last place a 0 occurs. So you can see there would have been a 0 here. Remove the 8, which would have been here. Remove the 2, which, where would the 2 have been? Right there, it's gone, et cetera, et cetera. So that works out really well. Okay. Now what I want to test is a neat little method to remove them all. Okay. Remove all of this data. So it essentially gets rid of all of the occurrences of the data in the linked list, all of them. Okay. This is a short little method. It's really not that complicated. If the data is null, return false. That's true. If it doesn't contain the data, so just like we had done up here, if it doesn't contain the data at all, well, then return false, not return null, but return false. There's nothing to remove at that point. Okay. But then this is a nice way you can use method dependency here. While it contains the data, while there's still data in the linked list, remove the data from the linked list. So the loop just keeps doing this over and over and over again until finally it's done and there's no more data contained in there. So that's a really cool method to remove it all. So I want to test that. And I'm going to do it by doing a clone again of copying list 1 onto list 2. Okay. And now I'm going to remove all method, okay, by spitting out list 2, getting the front, removing all of this data from the linked list. And then I'm going to do it again and again with different pieces of test data. Okay, removing it all. And yeah. Whew. Okay, let's see if remove all does what we hope it will do, which is to get rid of all of those numbers in the linked list. Okay, so it says I'm going to remove all the zeros out of this linked list. So you can see a 0 there, 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 and even there. So now when you look at the linked list on the after it's done its job, all the zeros have been removed. Then it said I'm going to remove all the 9s. Well, there was actually only 1 9 in the list, but it did remove it. Remove all the 8s. Well, there was 2 8s, 1 there and 1 there, and now they're gone. Okay. And then the 10, there is no 10s, so it didn't crash on that. It just was able to pull that off quite nicely. Okay. To test this one step further, I'm going to reverse the lines here. I'm going to do the 10 test first, which I know it can't remove. Then to do the random one, I think this would be kind of interesting if we did this over and over again. Rather than just do it once, I'm going to keep generating random data and keep removing it. That way, it's possible that the linked list will eventually just become completely empty because I've essentially removed everything. And I want to make sure that that still works. Even if the list is empty, will it still be able to handle that? So I think we've done this before. I'm going to have that loop go a certain number of times. I'll have it go size times. That's a constant that we have kicking around in our code somewhere. Don't remember exactly what it is, but I'll just use that. And let's run that test one more time. So now it's going to do that removal of all the stuff multiple times at the end here. And there you can see it's removing all the 1s, all the 7s, all the 5s, it's doing a pretty good job with that. But rather than be at random, how about this crazy thing? How about we make data into I? So it removes all the 0s, 1s, so it kind of goes through and removes everything. That might be a wacky test to run. Let's see how that goes. So remove 0. You know, that went pretty well, but I want to get rid of everything. So I think going back into my constants, since we're doing random numbers between 0 and 9, and where the heck did we build those things? I don't even remember. There we go. It's actually h, which is the highest possible number. So why don't we go all the way up to that? So why don't we go have our test go all the way less than or equal to h and start it at the low number. So start it at 0, go up to h. What's wrong with this? Double to int. Oh, okay. Them into ints. There we go. Let's see how that goes. I thought I ran it. There we go. Yep, there we go. That was my idea, was to eventually get all the numbers out until it was an empty list, which worked out really nicely. So it removed everything eventually out of the list. Sorry, bud, can't help you right now. And that's how I'm going to make that test a really solid test of removing all. All right. So now we have tons of options. But I'm going to throw a couple more remove methods on here, because you never know what you're going to use your linked list for. Okay, so this next one, again, pretty small, pretty simple. Okay, we've been able to remove them all. Let's overload this method. So another version of remove all, but this time it takes an array of items to remove. It's not just one item, but a whole array of them. Well, little error check. Items equals null. If there's nothing in this array, it's a null array. Return false. Nothing to do here. Nothing to do there. Okay. If items, the array, has a length 0, it's not null, but has nothing in it. Okay, well, nothing to do there. Return false. Then I will return true at the end of this, that I was able to remove them all, because I actually have an array now. And what I'm going to do is run a for loop, okay, through my, and actually, let's back this up a step. That's for loop. For every item in items, remove that item. Done. Simple way to write that. So it removes them all by just looping through using the enhanced for loop, all the items in that particular thing. For time's sake, I'm not going to write the test for this. I will put it in before I upload to GitHub, because I'd have to make an array of stuff to remove, and I'm just going to skip that for now. But I'm going to overload this method one more time and just change it from an array of items to a linked list of items. Okay, most of this code would be essentially the same. Okay, what would be different would be the for loop. The for loop would be different because I can't use an enhanced for loop this way. I'd use the standard for loop, go up to items size instead of using .length, and I would still remove an item, but I need to get that item. So I'm going to say items.get spot I, and that's how I would remove them all. The difference between an array and a linked list. And this is actually just using code that we have for this. Okay, and again, for time's sake, I'm not going to write the testing code for that. I'll put that in after the fact so you guys can see that. All right, wrapping up a last few little methods here. Okay, and all of these will get put in GitHub. Here's one that essentially is kind of like finalize. It's a clear method, but it doesn't actually completely destroy the list, but it kind of does. I make current equal to the head of the list, while current is not equal to null. List. Okay. Node next. Current dot next. This is kind of the idea. Okay. Then I can take current and finalize it, wipe out that current node. Then I can set current to be the next node. Move it to the next one, move it to the next one, move it to the next one, and then finally I can finalize the whole list at the end here. So the clear method is an even more powerful method than finalize. You might remember finalize, what it did was it set length to null, head and tail to null, and then cleaned up the garbage. But what the clear method is actually doing is going one step further. What clear is doing is traveling node to node and wiping out each node by calling its finalize method, which you might remember to wipe out a node, sets the data to null, sets next and previous to null, and cleans the system garbage. So it's a more of a thorough clearing than even finalize does. Whew. Okay, we are almost out of time. So what I actually want to show you, rather than take the time to write all the methods, is just summarize them all. Just 1 second. So what I'm going to do is I'm going to summarize the methods for you guys as to what they do. I will be putting those methods up into GitHub so you guys can get them with comments. But I'm going to summarize essentially what they do. I'm going to show you so that if you bring in this linked list class for your own use, you have a fully sort of fleshed out version of it that really I think will match up with what you might ever need for a linked list in terms of what's going on there. So to show you what it's going to look like, what I'm going to actually do is go to last semester's version of this. So I'm just going to go in my GitHub to last semester, which was semester 1 of this 1920 school year. And I'm going to go in, to the linked list code and just jump on some of these methods that we're not going to have time to do today. And I don't want to spend any time next week doing them either, because at this point you've learned all the basics of the linked list. Anything else I would show you would just be more and more extra stuff. So here are those methods. Okay, coming up. Okay, so there's one here called contains all. It takes an array of items and checks to see if all of the items in the array are also in the linked list. So it also uses a loop, and it depends on the contains method we already wrote once. So it pulls each item out of the array and checks it by looping through using things like enhanced for loops. Okay. I also then made a overloaded version of that in the same way works, but except it uses a linked list rather than an array. So the code is almost identical, except again, I switched to a standard for loop, and you have to use my accessor or my get method here to get it out of the linked list. Whereas with regular arrays, I don't need to do that. I can use square brackets to do that. Next method, add all method that takes an existing linked list and adds it, or I think the proper word would be appends it, onto the end of our current linked list. So this is a practical method. Like say you had a list of names, then someone gave you another list of names, you would add that list to the list you already have. Okay, then an overloaded version of add all does that again, but this time instead of adding it to the end of the list, it says I'll pick a spot, an index, and I'll insert it in the middle of the linked list at whatever index number I pass to it. And basically I can use methods I already have, like add after or just the add method to do this. So there's a lot of logic going into this other than using methods that we already have built. Then I have a add all with an array. I have it with the linked list. I have it with the array, same stuff with linked lists and arrays. This is a useful method. It's a sublist method. So I have two parameters I'm calling from and to. So I'm basically saying if you had like a list of names and I said, give me all the names from spot 5 to spot 20, it pulls a list out of the linked list, which is why it returns a linked list as the return type. So it's pulling it out of the linked list and giving you a sublist or a smaller list. So you can see here I used some in-range methods to make sure it's in range, because I don't want from and to be weird. I also want to make sure that the integers from and to are not colliding with one another. Like it doesn't make sense if I said, hey, give me all the names from spot 10 to spot 3. Don't you mean 3 to 10? Yeah, that's what I meant, right? So you got to make sure those numbers are in the right order. It uses the get method, it uses the add method, and it returns the list at the end. So it's a neat little method to do that. Then a from array method turns an array into a linked list, okay, by wiping out the existing linked list and then adding all the items from the array into it. Then I have a method that makes a linked list from another linked list. Same basic idea. Then this is a weird method. This is to go the other direction, turn the linked list into an array. And for this one, though, I actually have to make use of some code right here that actually uses something from Java called the array class. All arrays are actually a child of the array class, or an instance of the array class, which is built right into Java. Okay, so that's what this method does. It's a little more complicated. It's not long. It's only 1, 2, 3, 4 lines of code. ToString and equals we already have. Clone, finalize. We already have all these methods. The only other methods I will include, and they're up at the top here, is a few more constructor options for the linked list. Constructing a linked list from an array, which uses my fromArray method. Constructing a linked list from a linked list, which again uses a helper method. And that's about it. So everybody, oh, I guess I wasn't sharing my screen for all that. I was just talking. That's okay. That's going to wrap up this week, everybody. Have a good week. Next week, we'll just talk about wrapping up the school year and what that could do, what that looks like. And I want to be available for your questions. Okay, everybody, have a good week. See you next week.